Hello friends, welcome to Learner's Planet. Friends, this is our sixth session for polynomials. In the previous sessions, we have discussed about factor and remainder theorem. We have also solved a good number of problems and applications of factor and remainder theorem. In this session, we'll be continuing with the same. We'll be solving some higher difficulty level problems and word-based problems on factor and remainder theorem. So let's begin this session. Friends, you should revise the previous session before coming to this session because we'll be using remainder theorem and factor theorem as it is. Okay, now let's see this problem. The polynomials kx4 plus 3x cubed plus 6 when divided by x minus 2 leaves a remainder which is double the remainder left by polynomial this when divided by x minus 2. We have to find out the value of k. Very simple application of remainder theorem. Let's begin to do it. First of all, we have to find out the remainder when the polynomial is divided by x minus 2. Let's assume this polynomial to be px. Now, px is equal to kx4 plus 3x cubed plus 6. And let it be qx. So, qx is equal to 2x cubed plus 17x plus k, and we have to divide these polynomials by x minus 2. Let's assume it to be gx. Now what is the first step? Equate gx to 0 and get the value of x. So x minus 2 is 0, that means x is equal to 2. Now what will be the remainder if px is divided by gx? That is p2. Okay, so let's calculate p2. Now put the value of x as 2 in this expression. So 2 raised to 4 is 16. So it is 16k plus 2 cube is 8. 8 into 3 is 24. It's plus 6. So it is 16k plus 30. Now in this case we have to find out the remainder when qx is divided by gx. And what will be the remainder? It will be q2. So let's calculate q2. It's 2 cube, that is 8 into 2, 16 plus 17 into 2 plus k. So it is 16 plus 34 plus k, or we can say 50 plus k. Now if px is divided by gx, the remainder is 16k plus 30, and if qx is divided by gx, the remainder is 50 plus k. Now according to the question, this remainder is double of this remainder. So let's make the equation. 16k plus 30 is double of 50 plus k. Okay, so let's solve it. 16k plus 30 is equal to 100 plus 2k. That means 14k is equal to 70. That means k is equal to 5. Isn't it so easy? Okay. Now let's see this question. Let R1 and R2 be the remainders when polynomials this and this are divided by x plus 1 and x minus 2 respectively. If R1 minus R2 is 20, we have to find out the value of a. Let's assume this polynomial to be fx. So fx is equal to x cube plus 2x square minus 5ax plus 7. And let's assume this polynomial to be px. So px is equal to x cube plus ax square minus 12x plus 16. Now let's assume this to be gx and this to be hx. So gx is equal to x plus 1 and hx is equal to x minus 2. Now according to the question, first of all we have to divide fx by gx and we have to get the remainder, and that will be r1. similarly we have to divide px by hx, and whatever the remainder will be there is r2. Okay, so what is the first step? Equate gx to 0 and get the value of x. So x plus 1 is 0, that means x is equal to minus 1. So if fx is divided by gx, the remainder will be f of minus 1. So let's calculate f of minus 1. It's minus 1 cube, that is minus 1. Then minus 1 square, that is 1 into 2, it's 2. Then put value of x as minus 1 over here. So minus 5a into minus 1, it's 5a and it's plus 7. So finally it is 5a plus 8. Okay, now let's calculate the remainder in this case. If px is divided by hx, the remainder will be p2. Just put the value of hx as 0. So x will be 2. So the remainder will be p2. Now put the value of x as 2 in this case. So it is 2 cube, that is 8, plus 2 2s are 4 into a, 4a, minus 12 into 2, 24, plus 16. So it's 4a minus 24 plus 24, that is 0. So it's 4a only. Okay. Now, according to the question, this remainder is r1 and this is r2. And what relationship is given? r1 minus r2 is 20. Okay. Now let's put the value of r1 and r2 over here. So r1 is 5a plus 8 and r2 is 4a. So I put the value of r2 and I get an equation. So 5a minus 4a, that is a, is equal to 20 minus 8, that is 12. So we got the value of a, that is 12. Very simple problem. Simple application of remainder theorem. Friends, I hope you are getting the application of remainder theorem, and you definitely find it very easy if you practice well. Now try this problem. It's quite similar to the previous one. Just pause the session, try the problem on your own, then match your solution and answer with mine. Okay, let r1 and r2 be the remainders when polynomials this and this are divided by this and this respectively. If 2r1 plus r2 is 12, we have to find out the value of a. Okay, let's begin. F of x is x cube plus 2ax square minus 5x minus 7, and gx is equal to x cube plus x square minus 12x plus 6a. Now let's suppose this is hx. So hx is x plus 1 and this is maybe px is x minus 2. Now we have to divide fx by hx and get the remainder. Now what is the first step? Put hx equal to 0 and get the value of x, which is minus 1. So what will be the remainder in this case? It is f of minus 1. So let's calculate f of minus 1. So it's minus 1 cube, which is minus 1. Then minus 1 square will be 1, that is 2a. Minus 5 into minus 1, it's plus 5 and minus 7. So it's 2a minus 3. Okay, that is minus 1 plus 5 and minus 7, that is minus 3. Okay, and this is actually r1. That is the remainder in when fx is divided by hx. Similarly, we have to get the remainder when gx is divided by px. Now put px equal to 0. That means x is equal to 2. That means the remainder will be g2. So put the value of x as 2 in this expression. So 2 cube is 8 plus 2 square is 4 minus 12 into 2, 24 plus 6a. So it is 6a minus 12. Okay, and this is r2. Now we have been given a relationship between R1 and R2, that is 2R1 plus R2 is 12. Okay. Now let's put the value of R1 and R2 in this equation. It's 2R1, that is 2 into 2a minus 3 plus R2, that is 6a minus 12, and it is actually 12. Okay. Now let's solve this equation. 2 into 2a is 4a minus 6 plus 6a minus 12 is equal to 12. So it's 4a plus 6a is 10a. 10a is equal to 12 plus 6, 18 plus 2, 20. That means a is equal to 2. Okay. So we have solved the problem very easily. Now let's see this question. If f of x a polynomial such that when it is divided by x minus 1 and x plus 1, the remainders are respectively 5 and 19. We have to find out the values of a and b. Now, very simple application of remainder theorem. Let's begin. F of x is equal to x4 minus 2x cube plus 3x square minus ax plus b. Let x minus 1 be as gx. It's x minus 1, and hx is x plus 1. So first of all, we have to find out the remainder when fx is divided by gx. Now what is the first step? Equate gx to 0 and find out its root or 0. So x minus 1 is 0, that means x is equal to 1. Similarly, equate hx to 0 and get the root of hx. That means x is equal to minus 1. Now according to the remainder theorem, if fx is divided by gx, the remainder will be f of 1, and when fx is divided by hx, the remainder will be f of minus 1. So first of all, let's calculate f of 1. It's 1 minus 2 plus 3 minus a plus b, which is minus a plus b plus 2. Similarly, let's calculate f of minus 1. So it's minus 1 raised to 4. It's 1 minus 2 into minus 1, that is plus 2, plus minus 1 square into 3 is 3. Then minus a into minus 1 will be a, and then plus b. So finally we are getting a plus b plus 6. Now, according to the question, this remainder, that is when fx is divided by gx, it is 5, and this remainder is 19. Okay, so let's put the value of this as 5 and this is 19. Now we have to get the value of a and b. Let's wait. Now we have these two relations, and we have to find out the value of a and b. First of all, let's add both of them. So minus a and a will get cancelled. B plus b is 2b plus 2 plus 6 is 8 is equal to 19 plus 5, that is 24. So 2b is equal to 24 minus 8, that is 16, and b is equal to 16 by 2, that is 8. Now put the value of b in any of the equation and get the value of a. Okay, so I just put the value of b in this equation. So it's minus a plus 8 plus 2 is equal to 5. So 10 minus 5 is equal to a. That means a is equal to 5. So we got the value of a as 5 and b as 8. I hope you are clear. Now let's discuss some applications of vector theorem. In this question, we have to find out whether gx is factor of fx or not. Now what is factor theorem? According to the factor theorem, x minus a is factor of Px if PA is equal to 0. Okay, so let's apply the same concept over here. This is x minus a, that is a is 2 over here. You can compare it with x minus a is 2, or you can find out the 0 of gx or root of gx by equating it to 0. In both the cases, you will get the same value. Okay, now we have to calculate f of 2. Now if f of 2 is 0, then gx is factor of fx, and if f of 2 is not 0, then gx is not the factor of fx. So let's put the value of x as 2. 2 cube minus 3 into 2 square plus 4 into 2 minus 4. So it's 8 minus 12 plus 8 minus 4. So 8 plus 8, 16, and minus 12 minus 4, 16. So it's 16 minus 16, 0. That means f of 2 is 0. So that means x minus 2 is definitely a factor of x cube minus 3x square plus 4x minus 4. So we solve this problem by applying factor theorem. Okay, let's do one more problem. In this case, we have to find out whether gx is factor of fx or not. So what is the first step? Let's find out the 0 of gx or compare it with x minus a. So gx is x plus 1. We compare it by x minus a. So a is minus 1, or we can find out the 0 of gx, that is x is equal to minus 1. That means we have to calculate f of minus 1. If f of minus 1 is 0, in that case gx will be a factor of fx, and if f of minus 1 is not equal to 0, then gx will not be factor of fx. So just put the value of x as minus 1 in this expression. So it's minus 2 minus 4 plus 6. So it's 6 minus 6, 0. So we are getting 0. That means fx is, gx is factor of fx. Okay. Now let's see this question. We have to find out whether gx is factor of fx or not. So first of all, find out the 0 of gx. That is x is equal to minus 5. Now we have to calculate f of minus 5. So just put the value of x as minus 5 in this expression. So it's minus 5 cube plus minus 5 square plus 3 into minus 5 plus 175. So it's minus of 125 plus 25 minus 15 plus 175. So 175 plus 25, 200 minus 140, that is 60. So we are not getting 0 in this case. That means x plus 5 is not a factor of x cube plus x square plus 3x plus 175. Okay, isn't it so easy? Let's do one more problem. Now let's see this question. We have to find out whether x plus 3 is factor of fx or not. So first of all, let's find the 0 of gx. That is x plus 3 is 0. That means x is equal to minus 3. Now we have to calculate f of minus 3. So just put the value of x as minus 3. It's minus 3 cube minus 3 into minus 3 square plus 4 into minus 3 minus 12. So it's minus of 27. Then further it is minus of 27. Then it is minus 12 minus 12. So it is minus of 78. That means f of minus 3 is not 0. That means x plus 3 is not a factor of x cube minus 3x square plus 4x minus 12. Okay, I hope you are clear. Now see this question. Quite similar to the previous ones. We just have to put the value of x as root 2 to find out whether x minus root 2 is factor of 7x square minus 2 root x minus 6 or not. So x minus root 2 is 0. That means x is equal to root 2. Now we have to calculate f of root 2. So just put the value of x as root 2. So 7 into root 2 square will be 2 minus 2 root 8 into root 2 minus 6. So it's 14 minus 2. Root 8 into root 2 is root 16, and if root 16 comes out, it will be 4 then minus 6. Okay, so it's 14 minus 8 minus 6, that is 0. So f of root 2 is 0. That means x minus root 2 is definitely a factor of 7x square minus 2 root x minus 6. I hope you are clear. Now we have to prove that x minus 1 is a factor of x raised to 10 minus 1 and also of x raised to 11 minus 1. Now further we will apply factor theorem. Here suppose fx is x raised to 10 minus 1 and gx is x minus 1. Now we have to prove that x minus 1 is a factor of x raised to 10 minus 1. So first of all, let's find out the 0 of gx, that is x is equal to 1. Now we calculate f of 1. If f of 1 is 0, then x minus 1 will definitely be a factor of x raised to 10 minus 1. And if f of 1 is not equal to 0, then x minus 1 will not be a factor of x raised to 10 minus 1. So let's calculate f of 1. Just put the value of x as 1 in this expression. So it's 1 raised to 10 minus 1, that is 1 minus 1, that is 0. So if we put x is equal to 1, we get the value of this expression as 0. That means x minus 1 is definitely a factor of x raised to 10 minus 1. Similarly, we put the value of x as 1 in this expression. Let it be hx. So hx is equal to x raised to 11 minus 1. We calculate h1. If h1 is 0, then x minus 1 will be a factor of it. If h1 is not 0, x minus 1 will not be a factor of it. So it's 1 raised to 11 minus 1, that is 1 minus 1, that is 0. That means we have proved that x minus 1 is a factor of x raised to 10 minus 1 as well as x raised to 11 minus 1. A very simple application of factor theorem. Okay. Now, in this question, we have to prove that x minus 2, x plus 3 and x minus 7 are factors of this expression. So first of all, let's write fx as x cube minus 6x square minus 13x plus 42. Now we have to find out the zeros of all these three polynomials. Let it be gx, it's x minus 2. Equate it to 0, so x is equal to 2. Then let it be hx, that is x plus 3, that is 0. That means x is equal to minus 3. Similarly, let it be px is x minus 7. We have to find out the 0 of it, so it will be x is equal to 7. Now we have to calculate f2, f of minus 3 and f of 7. If they are 0, then all of these will be factors of this polynomial. So first of all, let's calculate f of 2. So let's put the value of x as 2. It's 2 cube minus 6 into 2 square, that is 4 minus 13 into 2 plus 42. So it's 8 minus 48, 24 I'm sorry, minus 26 plus 42. That means it is 0. Okay, so that means x minus 2 is definitely a factor of x cube minus 6x square minus 13x plus 42. Now we have to find out whether x plus 3 is a factor or not. So let's calculate f of minus 3. It's minus 3 cube minus 6 into minus 3 square, that is 9, minus 13 into minus 3 plus 42. Okay. So it is minus 27 minus 54 plus 39 plus 42. So further it is 0. That means even x plus 3 is a factor of x cube minus 6x square minus 13x plus 42. Now we have to find out for x is equal to 7. Now let's calculate f of 7. So it's 7 cube minus 6 into 7 square minus 13 into 7 plus 42. So it's 343 minus 6 into 49, that is 294 minus 91 plus 42. So further it is 0. That means even x minus 7 is factor of x cube minus 6x square minus 13x plus 42. So quite simple question. Now let's see this question. Use factor theorem to verify that x plus a is a factor of x raised to n plus a raised to n for any odd positive integer. So let's assume this expression to be fx. Fx is equal to x raised to n plus a raised to n, and this is maybe gx. Now according to factor theorem, if x plus a is factor of x raised to n plus a raised to n, then if we put x is equal to minus a, that means f of minus a should be 0. Okay, so x plus a is 0, so x is equal to minus a. So if f of minus a is 0, then x plus a will be factor of x raised to n plus a raised to n. Okay, so let's calculate f of minus a. So f of minus a is equal to minus a raised to n plus a raised to n. Now here there are two cases. Case 1, if n is even. If power is even, then even power of negative will convert it to positive. Okay, so in that case it will be a raised to n plus a raised to n, that is 2 times a raised to n. So if n is any even number, x plus a will not be a factor of x raised to n plus a raised to n. Now case 2, if n is odd. Now if n is odd number, the odd power of any negative number will leave negative, so it will be minus a raised to n plus a raised to n, which will be 0. That means if n is any odd number, then x plus a will definitely be a factor of x raised to n plus a raised to n. So we can prove it. Here in this question, we are provided with the information that we have to find out it for any odd positive integer. That means n is an odd positive integer. So in that case, x plus a will definitely a factor of x raised to n plus a raised to n. Okay, which we have established over here. So I hope you are clear. Now in this question we have to find out the value of a if x minus a is a factor of polynomial x cube minus a square minus 1x plus 2. Let this polynomial to be fx. So fx is x cube minus a square minus 1x plus 2. Okay. Now we are given that x minus a is a factor of it. Let x minus b as gx. It's x minus a. So first of all equate it to 0. So we get x is equal to a. If x minus a is a factor of fx, that is x cube minus a square minus 1x plus 2, then f of a will be 0. So let's calculate f of a. Let's put the value of x as a in this expression. So it is a cube minus a square minus 1 into a plus 2, and it should be 0 if x minus a is a factor of it. So let's calculate. It's a cube minus a cube plus a plus 2, which is 0. That means a is equal to minus 2. Okay, so we got the value of a as minus 2. Friends, I hope you might have enjoyed the session and you might have learned the application of factor theorem and remainder theorem. We'll be taking more such questions of factor theorem in our next session. Till then, do revise this session and let's see in the next session. Bye bye.